Hello students, welcome back to my channel CGAT Maths. Myself Dr. Suresh brother. In this video, we are going to discuss an example based on finding the derivative of analytic function. It's a type 1 example. A type 1 example, that is verification of analytic function and finding the derivative of analytic function. Okay, so we have, student, here we have an example. Find the derivative of analytic function f of z is equal to z plus e raised to z. We can take f of z is equal to z plus e raised to z. First, here we need to find out the real and imaginary parts. To find out real and imaginary part, in the left side, we are going to substitute f of z by u plus iv, and in the right side we have two options. We need to substitute z is equal to either x plus iy and or e raised to I theta, depending upon the given example. Okay, here the left side we are going to substitute as a u plus iv. The right side I am substituting z is equal to x plus iy plus e raised to x plus iy. Fine. So u plus iv is equal to x plus iy, right as it is, plus this is the exponent power consists of sum of two terms. You can able to split it as e raised to x into e raised to iy. The reverse order is when bases are same, powers are added. If power is a sum of two terms, you can able to split separately. Fine. This is x plus iy, right as it is, plus e raised to x, right as it is, and e raised to iy, or we know that e raised to I theta. E raised to I theta is cos theta plus I sin theta. So e raised to iy becomes, this is cos y plus I sin y. Fine. Now further, this is x plus iy plus, to multiply, e raised to x into cos y is e raised to x cos y plus e raised to x into I sin y is I into e raised to x sin y. So left side is u plus iv. Now you can equate real and imaginary parts. On equating real and imaginary parts, u is equal to, right side real parts are x plus e raised to x into cos y. Similarly, imaginary part v are y, that is coefficient of y plus e raised to x into sin y. So now, after getting this, we are going to find out partial derivative of u and v with respect to x and y. So why we are finding the partial derivative of u with respect to x and y and v with respect to x and y? To verify the analyticity. Okay, so for that you differentiate u and v with respect to x and y, that is partially. So what will happen? Fine. Now dou u by dou x Dou u by dou x is first x. X contains only, sorry, first term contain only x alone. So x with respect to x is 1. For the second term, it is e raised to x into cos y. We are differentiating with respect to x. So it is treated as a constant by the principle of partial differentiation. So cos y is constant. Differentiation of e raised to x is e raised to x. Similarly, dou u by dou y. So first term is x alone. With respect to y, x becomes 0. Plus, with respect to y, e raised to x is constant. We are writing outside. Differentiation of cos y is minus sin y. Fine. Similarly, to get what is v with respect to x. V with respect to x, first term is y. With respect to x, y becomes 0. Second term, with respect to x, sin y is a constant, writes outside. Differentiation of e raised to x is e raised to x. Similarly, v with respect to y becomes 1 plus, with respect to y, e raised to x is constant. Differentiation of sin y is cos y. Now, we have CR equations. We have Cauchy-Riemann equations in Cartesian form. That is, dou u by dou x equal to dou v by dou u by dou x equal to dou v by dou y, and dou v by dou x equal to minus dou u by dou y. So let us verify this. The verification is very easy. First, let us take the, you can call it as equation number 1 and equation number 2. So LHS of 1. LHS of 1 is dou u by dou x. What is dou u by dou x here? 1 plus e raised to x into cos y. Okay. And this is same as 1 plus e raised to x into cos y, that is dou v by dou y. So which is same as RHS of 1, dou v by dou y. So what is your conclusion? First CR equation is satisfied. Similarly, go for LHS of 2. What is LHS of 2? Dou v by dou x. Dou v by dou x is e raised to x into sin y. This can be also written as minus times of minus e raised to x into sin y. And this is same as minus e raised to x into sin y is same as dou u by dou y, which is same as RHS of. So what is your conclusion? Therefore, CR equations are verified and f of z is equal to z plus e raised to z is analytic. Okay, fine. So now we need to find out its derivative. For that, we need to consider f dash of z is equal to dou u by dou x plus I into dou v by dou x. This is the case 1 result while deriving the CR equations in Cartesian form. So just substitute dou u by dou x and dou v by dou x. Let's go back. Okay, let us copy this. Fine. Fine. Just replace du by du x and du by du x here. F dash of z is equal to du by du x is 1 plus e raised to x into cos y plus I times of e raised to x into sin y. This is same as 1 plus. In second and third term, e raised to x is common and write it as cos y plus I sin y, which is equal to 1 plus e raised to x into, you know that cos y plus I sin y is same as e raised to iy, which is equal to 1 plus, when bases are same, powers are added, e raised to x plus iy, and substitute x plus iy is z. So we have f dash of we have f of z is equal to z plus e raised to z. By differentiating z with respect to z is 1 and e raised to z is e raised to z. So this is the derivative of f of z. Thank you so much for watching. We'll meet in the next video.